Have you ever wondered about the invisible shield that protects our solar system from harmful cosmic rays? Welcome to the fascinating world of the heliosphere. This colossal bubble, driven by the sun, encompasses our entire solar system and stretches well beyond the furthest planet. It's an intricate dance of solar wind and magnetic fields, forming a protective barrier against the onslaught of cosmic radiation. This invisible shield is born from our sun's constant outpouring of charged particles, creating a wind that rushes out into space at incredible speeds. The force of this wind expands outwards, pushing against interstellar space and forming this protective bubble. The heliosphere, though unseen, plays a crucial role in protecting our solar system. It's our first line of defense against the cosmic rays that pervade the universe, making life as we know it possible. So let's delve deeper into this unseen guardian of our celestial home. The heliosphere is more than just an invisible shield. It has layers, boundaries, and a complex structure. Dive into the heart of the heliosphere and you'll find a fascinating cocktail of elements. The primary component is the solar wind, a stream of charged particles continuously ejected from the sun. The solar wind, in essence, creates the heliosphere, pushing against interstellar space and carving out a protective bubble around our solar system. But it's not just about the solar wind. The heliosphere also houses magnetic fields, invisible lines of force generated by the sun. These magnetic fields are carried out into space by the solar wind, giving the heliosphere its characteristic shape. Now let's talk boundaries. The heliosphere isn't a one-size-fits-all kind of structure. It has layers. The first boundary we encounter is the termination shock. This is where the solar wind, traveling at supersonic speeds, slows down abruptly and becomes subsonic. It's like a cosmic speed bump, marking the point where the solar wind begins to feel the pressure from the interstellar medium, the space between stars. Beyond the termination shock, we reach the heliosheath. This is a turbulent region where the solar wind slows down and heats up, and the magnetic field strengthens. The heliosheath acts as a buffer zone, a final frontier before we reach the edge of the solar system. Finally, we arrive at the heliopause. This boundary marks the edge of the heliosphere and the start of interstellar space. It's where the pressure of the solar wind balances with the pressure of the interstellar medium. Beyond this point, we're no longer under the sun's influence. The heliosphere's layered structure and diverse components make it a unique feature of our solar system. So that's a whirlwind tour of the heliosphere's composition and structure. It's an intricate system, a delicate balance of forces and particles, all working together to shield us from cosmic rays. But remember, the heliosphere isn't static. It breathes, it moves, it evolves, all under the influence of our ever-changing sun. The solar wind, a constant stream of particles from the sun, plays a significant role within the heliosphere. But what exactly is this solar wind? Picture a gust of charged particles, primarily composed of electrons and protons, being continuously blown out from the sun's corona or outermost layer. This gust, traveling at incredible speeds, is what we know as the solar wind. The solar wind isn't a gentle breeze, though. It's a high-speed, high-energy cosmic force with speeds that can reach up to 1,000,000 miles per hour. And it's not just a straight line from the sun to the outer edges of the solar system. It's a complex, swirling, turbulent flow that carries with it the sun's magnetic field. Now let's talk about the impact of this solar wind. It affects everything within the heliosphere, from the smallest dust particles to the largest planets. It's the solar wind that shapes the beautiful luminous tails of comets as they streak across our night sky. It's also responsible for the auroras, those breathtaking light displays we see in the polar regions of our Earth. But the solar wind does more than just create celestial light shows. It also interacts with planetary magnetic fields, including Earth's. This interaction can cause disturbances in our planet's magnetic environment, leading to phenomena like geomagnetic storms. These storms can have real-world effects, impacting satellite communications, navigation systems, and even power grids. Beyond our own planet, the solar wind affects other celestial bodies within the heliosphere. For instance, it has played a key role in stripping away the Martian atmosphere, transforming Mars from a warm, wet world into the cold, barren planet we know today. So, you see, the solar wind is far from just a gust of particles. It's an influential cosmic force that shapes our solar system and impacts our daily lives. The solar wind, a key player in the heliosphere, significantly influences our solar system. Magnetic fields within the heliosphere interact with the solar wind, creating fascinating phenomena. To truly understand the role of these magnetic fields, let's start from the very heart of our solar system, the Sun. The Sun is not just a ball of blazing energy, it is also a colossal magnet. The Sun's magnetic field extends far beyond its surface, carried by the solar wind, and forms an enormous magnetic bubble known as the heliosphere. Now imagine this heliosphere as a gigantic invisible shield protecting our solar system from harmful cosmic radiation. But the magnetic field within the heliosphere is not static. It changes and fluctuates, influenced by the Sun's rotation and the solar wind's flow. This dynamic nature of the magnetic field results in a complex, ever-changing pattern known as the Parker spiral, named after the astrophysicist Eugene Parker. The Parker spiral is not just a beautiful cosmic pattern, it's a crucial part of the heliosphere's structure. The solar wind carrying the Sun's magnetic field moves at supersonic speeds, creating a spiraling pattern that extends across the solar system. This interaction between the solar wind and the magnetic field leads to some intriguing phenomena. One such phenomenon is magnetic reconnection, a process where magnetic field lines from different sources combine and rearrange themselves, releasing a tremendous amount of energy. This energy can accelerate particles to nearly the speed of light and is responsible for many solar activities, including solar flares and coronal mass ejections. These interactions also play a significant role in shaping the outer boundary of the heliosphere, known as the heliopause. In this region, the solar wind slows down and the magnetic field strength decreases, marking the edge of our solar system. Magnetic fields interacting with the solar wind shape the heliosphere and contribute to its complex nature. Understanding these interactions is not just about satisfying our curiosity, it's about understanding our place in the cosmos and how our solar system interacts with the vast universe beyond. The Voyager missions have greatly contributed to our understanding of the heliosphere. Launched in the late 70s, Voyager 1 and 2 have been our eyes and ears in the farthest reaches of the solar system and beyond. Their primary mission was to explore the outer planets, but their journey didn't stop there. They continued their voyage, venturing into the unknown, making them the first human-made objects to leave our solar system. Let's take a brief detour and focus on these two intrepid explorers. Voyager 1, currently the most distant human-made object from Earth, crossed the heliopause, the boundary of the heliosphere, in 2012. This marked its entry into interstellar space, a realm filled with cosmic rays and particles from distant stars. On the other hand, Voyager 2, not far behind its twin, entered interstellar space in 2018, providing us with a different perspective of the same boundary. These twin spacecrafts have made groundbreaking discoveries. They've explored the outer planets in detail, studying their atmospheres, moons, and magnetic fields. They've provided us with our first close-up views of Jupiter's turbulent atmosphere, Saturn's stunning rings, and the icy moons of Uranus and Neptune. But their most significant contributions lie in their journey beyond the planets, into the heliosphere and the interstellar space. Voyager 1's discovery of the heliosheath, a turbulent region where the solar wind slows and merges with the interstellar medium, was a revelation. This region, much further from the Sun than anticipated, drastically changed our understanding of the heliosphere's structure. Voyager 2, with its functioning plasma science experiment unlike its twin, has been able to directly measure the temperature, pressure, and density of the interstellar medium, providing us with unprecedented data. The Voyager missions, journeying beyond the heliosphere, have provided us with invaluable insights. They've reshaped our understanding of our cosmic neighborhood and continue to send back fascinating data from the edge of the solar system and beyond. As they journey further into the unknown, who knows what other secrets they'll uncover. Our understanding of the heliosphere continues to expand, thanks to ongoing research and future exploration plans. As we speak, scientists around the globe are working tirelessly, using cutting-edge technology and sophisticated models to unravel the mysteries of our cosmic shield. One of the exciting areas of research is the study of solar wind. By understanding the behavior of solar wind, researchers hope to gain insights into how it shapes the heliosphere and impacts our solar system. This could also help us forecast space weather, which is crucial for the safety of our satellites and astronauts. In addition, scientists are investigating the intriguing boundary regions of the heliosphere, like the heliopause and termination shock. These areas, where the solar wind slows down and merges with the interstellar medium, hold clues about the interactions between our solar system and the broader galaxy. Now let's talk about future exploration. the great success of the Voyager missions has motivated new ventures to the edge of our solar system and beyond. For instance, the Interstellar Mapping and Acceleration Probe, or IMAP, set to launch in the mid-20s, aims to study the heliosphere's boundaries and the cosmic rays that permeate it. Meanwhile, the planned NASA mission, Solar Orbiter, will provide unprecedented close-up views of the Sun's polar regions, offering deeper insights into how the Sun generates and controls the heliosphere. Another mission on the horizon is the European Space Agency's THOR, or Turbulence Heating Observer, set to explore how turbulent plasma heating in the solar wind affects the heliosphere. In a nutshell, the research and exploration efforts of today are paving the way for a better understanding of our cosmic neighborhood. These missions will not only advance our knowledge of the heliosphere, but also help safeguard our journey into the cosmos. The future of heliosphere exploration promises to reveal even more about this fascinating part of our solar system. Did you know heliospheres are not exclusive to our solar system? They can exist in other star systems as well. That's right. The protective bubble that shields our solar system is not a unique phenomenon. The heliosphere, as we have explored, is a result of the solar wind interacting with the interstellar medium. This means any star that emits a stellar wind could potentially have its own heliosphere. These star-specific heliospheres are known as astrospheres. Astrospheres are fascinating because they can provide us with insights about other star systems. For instance, the shape and size of an astrosphere can tell us about the star's wind speed, its age, and whether it's a solitary star or part of a binary system. By studying astrospheres, we can also learn more about the interstellar medium. The interstellar medium is the stuff that fills the space between the stars. It's composed of gas, dust, and cosmic rays, and it's key to the birth and death of stars. So understanding the interstellar medium is essential for understanding the life cycle of the universe itself. Astrospheres also play a role in the search for extraterrestrial life. Just as our heliosphere shields us from harmful cosmic rays, an astrosphere could protect planets in other star systems. If we can detect an astrosphere around a star with exoplanets, it could be a sign that those planets are more likely to host life. Currently, our ability to study astrospheres is limited by the technology we have. However, with the advancement of space telescopes and probes, we are making strides in this field. The future of astrosphere research is exciting and promises to reveal more about our place in the cosmos. In conclusion, heliospheres or astrospheres are not just shields for our solar system, but gateways to understanding the universe. They offer us a glimpse into the life of stars, the interstellar medium, and the potential for life beyond our planet. Studying heliospheres beyond our own solar system can offer us a window into the vast universe. As we come to the end of this enlightening journey, let's recap what we've learned about the heliosphere. This vast, invisible region extending more than 10 billion miles from the Sun acts as our solar system's protective shield, warding off harmful cosmic rays. We've delved into its composition and structure, understanding how the heliosphere is formed by solar wind and magnetic fields. These elements create layers and boundaries, such as the heliopause and termination shock, which define the edges of our solar system. We've also explored the characteristics of the solar wind, a constant flow of charged particles from the Sun. This solar wind shapes the heliosphere and impacts planets and other celestial bodies within it. The interplay between the solar wind and magnetic fields leads to a variety of fascinating phenomena, all part of the dynamic environment of our heliosphere. Furthermore, we've highlighted the importance of the heliosphere's influence on the planets within our solar system. Each planet, from Mercury to Neptune, experiences the effects of the heliosphere in unique ways. The monumental Voyager missions were also discussed, shedding light on their invaluable contributions to our understanding of the heliosphere. These missions have enabled us to venture beyond the boundaries of the heliosphere, leading to groundbreaking discoveries that continue to intrigue scientists and space enthusiasts. We've also touched upon the field of heliophysics and the impact of space weather, which are crucial to studying the heliosphere and understanding its effects on Earth and other celestial bodies. The ongoing research efforts and future exploration plans promise to further our knowledge of the heliosphere. Through these endeavors, we will continue to learn more about this vital region of our solar system and its role in the universe. Finally, we've explored the concept of heliospheres beyond our own solar system, recognizing how studying these can contribute to our broader understanding of the cosmos. The heliosphere, our solar system's protective shield, continues to captivate scientists and space enthusiasts alike. Until next time, keep exploring and stay curious.